Today we will create this weather app using OpenWeatherMap API. The app will be using JSON with a sink and await to fetch the weather and populate the view. For example, if you wanted to search for the weather in Cape Town, we just type in Cape Town, click on Celsius and it displays the temperature in Celsius, and then we can do the same thing for Paris. You can select Celsius, Fahrenheit or Kelvin, and for Paris there's a temperature 7.4 Celsius. And also we can do the same thing for London to check the weather. Type in London, select Celsius, and here's the temperature and other descriptions that come with it, the humidity, the wind speed. So this is the application we're creating in this tutorial. To use OpenWeatherMap API, you need to register on openweathermap.org to obtain your API key. The OpenWeatherMap API returns this JSON payload. The information we'll be extracting from the payload includes the following: the name, which includes the city name or the country name. We'll be extracting that key, and also we need to extract the temperature, which is here, and the humidity. And we also need to extract the wind speed, which is here in this struct. Within your Xcode project, create a new file called weather response. The next thing we need to do is to create our structs so that we can parse and extract the key value pairs from the OpenWeather API. Type in struct weather model codable let name string let main weather info. We'll be creating that later. That object. Let weather with weather description. And that will be an array of weather description. Let wind equals, colon wind info. Now we need to create our main weather info struct main weather info. It's codable. Let temp double, let humidity double, And now we need to create our weather description strut. Weather description, codable, let description, string, let icon, string, strut, wind, info, codable, let speed, double. I'll just compile it. Now we have to create our weather service class so that we can interact with the API. Just select Swift file, click on next. Enter the name of the class called weather service. And then just click on create. Then we just create our class weather service. So this is an empty class at the moment. Now we need to create our enum temperature, temperature unit, string, case, iterable. That means we can loop through each of the cases of the enum. Case, Celsius, case, Fahrenheit, case, Kelvin. We also need to create another enum to capture when there's a decoding error or some type of error happens. Enum, weather, error, case, invalid, URL, and case, decoding error. Now, within our weather service class, we need to assign our API key, but you have to use your own API key because my API key won't work for you. The next thing we need to do is to create another variable to hold the URL. We just call this base URL. And the URL is https://api.open weather map.org data 2.5. The endpoint is weather. Now we need to create our method to fetch the temperature. Type in fetch weather city string and the units, temperature units, async throws weather model. This function fetch weather, what it will do, it will fetch the weather data for a specified city and a temperature. The next thing we need to do is to construct the URL. That will include the city and the API key and the desired temperature unit such as Kelvin, Celsius or Fahrenheit for the actual unit, temperature unit. So just type in encoded city equals city dot add percent encoding with allowed characters. Dot URL query allowed. Let URL equals URL string base URL question mark q encoded city ampersand app ID equals, and then we apply our API key, ampersand units, and it should be units, equals unit dot raw value. Else, if there's some type of error, we just throw the error back to the calling methods, throw weather error dot invalid URL. The purpose of using the function add percentage encoding is that it will enable the user to type in spaces for their city or their country that they want the temperature for. So they can type in spaces within their text field. And then the URL will always return the correct data. The correct response will always be returned. The next thing we need to do is to make the API request to do an actual call. So just type in let data equals try await URL session shared data. Data from URL. And now we need to decode our data so that we can access the data within our objects. Let weather equals try JSON decoder decode weather model self from data. So what that does, we're just getting the decoded data as an object using weather.self. So it's not an array or a dictionary, it's just one single record, one single result, but within an object. Return weather patch throw weather error dot decoding error. So that's what happens if there's a decoding error. It will be thrown back to the caller. I'll just compile it. To include some separation of concern, next week we'll be implementing the Model-View-Model. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In today's tutorial, we will implement the View model that will be used to call the Weather service. Create a new SwiftUI file and call the new file Weather-View-Model. We can delete the preview. Instead of using a struct, we're using a class. And instead of implementing or inheriting from the view, will be inheriting from observable object, because we want to detect all of the changes that has happened on this object. So we select observable object. And also delete the lines between 11 and 13. Next thing we need to do is type @main actor. The @main actor attribute in Swift is used to specify that a particular piece of code should be executed on the main thread. The main thread is a thread that is responsible for performing updates to the UI. To publish these changes, we need to create a few publish variables. So just type in @publish bar selected unit temperature unit equals .Celsius. So that's the default temperature. @publish var city @publish bar weather model, which is optional. @publish bar is loading equals to false. Next thing we need to do is to create an instance of our weather service class. This is a private variable, private let weather service equals the weather service. Now we need to enable the Weather-View model to fetch the weather from the weather web service. So we need to create a function called fetch weather, and this will be fetched asynchronously. Is loading true, as we're now trying to fetch the weather. So we need to capture any errors that could happen. I'll just create the catch block, display any errors to the screen, to the console. Error fetching weather, and display the error. And then is loading equals false. Back in the do block, let weather data equals try await weather service dot fetch weather for city .Celsius. On line 24, what we're doing, we call the weather service to fetch the weather data for the specified city and unit. And now we need to store that fetch weather within another variable, which is called weather. Weather equals weather data. Now let's compile it. Within your weather app file, which should be similar to this one here that I'm selecting at the top here, we need to inject our weather view model as an environment object so that it's shareable within the application, within any direction. So open your weather app file and then type in the following: at state object private var view model equals weather view model. And then we will inject the actual view model within our content view dot environment object view model. So now the content view has access to the view model. I'll compile it again. Next week we will start on the content view to enable more interaction within the application. So within the content view we'll be able to display our weather forecast and to interact with the API. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In this tutorial, we will start to create our UI within our content view. Delete lines 22 to 26. And then add the following variables: at environment object private var view model weather view model. At state private var is menu open is equal to false. The purpose of lines 12 is menu open is equal to false is to enable the user to select the following temperature units on the UI. So the user can select their temperature units such as Celsius, Fahrenheit and Kelvin to do the conversions of the temperature. We next need to delete the lines between 14 and 20. And now we need to add a navigation view. Navigation view. zstack alignment dot top trailing and now we need to add a linear gradient to the view. Gradient, and now we add our array of colors. Color.blue, color.white, for the starting point, dot top, and the end point, dot bottom. Ignore safe area. Next thing we need to add is our VStack that will contain a caption for our app, like a title for our app, which is called weather app dot font slash title dot foreground color white, padding top 20. Within our VStack, we also have a horizontal stack, a H-stack, image, system name, magnifying glass, dot foreground color white. And we also need a text field to enter the name of the city or the country we want to retrieve the temperature from. Text $ViewModel.city. So we bind or assign the values that we're entering within the text field. We bind the actual value to the ViewModel.city. Text field style rounded order text field style. Dot foreground color dot black spacer button action with animation self dot is menu open dot toggle. The purpose of the spacer is to push the following elements to the right. Need a semicolon, And the purpose of line 36 is menu open toggle is to hide and show the menu, which is the temperature unit menu. On line 38, add the following bracket, and then we add our image that we want to be displayed. On our bottom, system name, ellipse, circle, dot fill, dot resizable, dot frame, width 30, height 30, dot foreground color blue, dot padding trailing 20. And then the next thing we need to do is display the weather details, like the weather summary, if it's available, that is. So we first need to do safe unwrapping. If let weather is equal to ViewModel dot weather. So if there's a weather results in the view model, then we need to display our weather detail view. So I just add a comment here for later. We'll add the weather detail view. We'll add that view later. Next thing we need to do is to display a loading spinner whilst fetching the weather data, so the user knows that something is happening and the application hasn't just paused. ViewModel dot is loading progress view, progress view style, circular progress view style, progress view style, we need to assign or pass in our tint blue, circular was spelled incorrectly. I typed in circle instead of circular, so yeah, I'll fix that now. And then we need to add scale effect 1.5, and padding. The next thing we need to check is to see if the temperature unit view is opened or not. We do this after lines 57. If is menu open, so if it's true to display the temperature menu view, then we will display it. So just create another comment here, add temperature menu view. The next thing we need to do is to create a close button. We do that after line 66. The close button purpose is to enable the user to close the temperature menu view. Let's type in struct close button. If you want to, you can create this view within another Swift file. Var action void. The purpose of line 70 is to define a property named action, which is a closure that takes no parameter and returns void. So that closure will enable the view to be dismissed. Var body button action image system name xmark dot circle dot fill dot resizable dot frame width 24, height 24, dot foreground color dot red. Now I'll just run it to see what it looks like. As you can see, at the moment we can't retrieve any weather details because we need to implement our view to enable us to select our weather unit. And that's what we'll implement in our next tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In today's tutorial, we'll be adding the temperature unit view to enable the user to select Celsius, Fahrenheit and Kelvin as their temperature conversion. Within your SwiftUI project, create a new file called temperature menu view. Select SwiftUI. Call the file temperature menu view. We can delete our preview. After lines 10, add the following. At binding bar is menu. Open. This is bool. The open should be a small p, and not a capital P. And the purpose of is menu open is to control the menu item state. Is to show and hide the menu that will be passed from the previous view, which is the content view. So from the content view, if we pass a true, that means we want the menu to be displayed. Private let temperature unit equals temperature unit dot Celsius raw value temperature unit dot Fahrenheit dot raw value temperature unit dot Kelvin dot raw value. On line 13, what we're doing, we're passing the three temperature elements to the temperature unit variable. So it holds an array of two elements starting from 0. At observed object bar view model weather model. So there we create a weather view instant object variable, and we need to detect any changes that's happened within the weather model, within the view model. And the detection will be done using observed object. Next thing we need to do is type in vstack spacing 10 for each temperature units. So each temperature unit will have an ID, a unique ID, and each of the temperature units' unique ID will be generated from a string. Button, action, with animation, self.isMenu open equals false. And then the next thing we need to type in is view model selected unit equals temperature unit. Raw value unit dot Celsius. And what that does, it sets the selected units in the view model based on the raw value of the selected temperature unit. And now we have to fetch the actual weather. So we need to use task so that it's done on the background thread. Fetch weather. And now we need to create a caption for our temperature unit button that will be displayed. Unit dot font headline dot foreground color dot white dot frame width 150, height 40, dot background blue, dot corner radius 20, dot shadow color dot gray, opacity 0.5, radius 3, x 0, y 3. So here we're just styling the caption of the button. After line 40, we need to add a bit more padding. 10. Background. Color. White. Opacity. 0.8. Corner radius. 20. Dot shadow. It's a little bit similar to this one, so I'll just copy and paste it. The Y parameter that should contain a value 5. And also the radius that should contain a value which is 5. Everything else is the same. The next thing we need to do is go back to our content view . On line 60, we can delete the comment, which is add temperature menu view. And now we will call our temperature menu view from the content view. Temperature menu view is open. $ is menu open. We need to pass the view model. View model. Dot frame. Max width. Infinity. Max height. Dot infinity. And the purpose of using infinity for width and height is to make sure the width and height is always the same size and the same length. Dot background. Color. Dot white. Dot opacity. 0.9. Dot corner radius. So we can have curved corners. Dot shadow. Color. Color. Dot gray. Opacity. 0.5. Radius. 10. X. 0. Y 10. We also need to create an overlay. And also we need to push the close button to the top. And also align the close button to the top as well. We need to create another overlay for the close button. Close button. With animation self.isMenu open.toggle. So what that does, when the user clicks on the close button, it toggles it. So if it was true, then it flips it to false. If it was false, it flips it to true. Next thing we need to, oh, you missed out something on line 66. On line 66, on this line, we need a comma. On lines, or after line 74, we need to add a bit of padding. Let's give it 20. Alignment dot top trailing. And that will align the close button to the top right corner. Now we can try to run it and see if it works or not. As you can see, we can now see our units, our temperature units, which is Celsius, Fahrenheit and Kelvin. So the next thing we need to do is implement our weather details view, because at the moment if I enter a city, it doesn't display the temperature for the city, because we need to implement the weather details view. And that's the final thing we will do in the next tutorial for the weather app, and also complete the remainder within the content view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.